K-mean clustering, first of all, unsupervised machine learning algorithms, whereas we are not having Y factor, which is used for training a data source. So first time we are going for unsupervised, wherever we are having input only, output is not there with us. So K-mean clustering is a type of unsupervised learning where we have unlabeled data, means Y factor is not there. We need to get a Y factor first before applying to supervised learning on the data values. So goal of this algorithm is to find the groups based on their clustering, and number of groups are represented by K. That's why we call it K-mean. So we'll see what are the mathematical behind this. So it result in the form of centroids of cluster K clusters. Will the centroid nothing but is a you can say position in a graph which represent as a center point of your data values. When say center point, it might not be a center point physically, but it have a median value which represent, it is a mean value of representing your data points. That's why we are calling it K-mean. Let's see what how we calculate this K-mean. Before going to that, let me take up. So we are having this sort of data. So I've been asked to make the group of 2 using these data points. So this is my distance features, and this is my speed feature, which is available. So I can have let me have 2 centroids. One I put it here, second I put it here. Center points. So I can make a group like this. I can make one group of this, and second group I can make it of this. How we identify this? This all data is belong to this group, this centroid, and this data belong to this centroid, because we will be using the similar concept of K and N of identifying a group based on distance. So all the data points having the nearest distance with this right side centroids would be allocated to this group, and similarly the lower distance with this centroid would be allocated to this group. So that's a case which are available. We can name it A and B group based on distance. Suppose I'm referring to this data points. So if I get the distance of this data point with this A group versus B group, so A group distance would be lesser as compared to your B group distance. So this value would be associated with the first group, which is A1. Similarly, if you refer this data of this value, so this is the more nearest than to this value. So it's identify the distance which is nearest and allocate the group accordingly. So for this, for identifying this centroids, its algorithm will run some random values to calculate the centroids. So let's me take one example there. So I'm having one sheet with me. So we are putting some numbers. Say let me take some numbers here. I'll say let me take a number from my presentation so that I can easily refer this. 2, 4, 10, 12. 2, 4, 10, 12. Then I'll go for 3, then 20 and 30 and 11 and 25th. Fine. So that is my x value, you can say. So I've been asked to make 2 centroids. I am working on K2. So I taken 2 random centroids. One I say I'll take one centroid as 4 and 11. I say first is 4. Let me write it on the same line. K 11. So these 2 centroids will be used to get a distance with existing values, and will be having absolute values of distance with your centroids. Suppose I am having so I should say number rather than digits. So K4, if you minus K4, so you will be using positive negative. I am referring it to ABS, which is an absolute value, So let me drag it. Similarly, I do it for my 11 ABS. Distance of this value, it is 11. Right. So let me associate the values of cluster. So this file, let me refer this as a C1. Then I refer this as a C2. So I'll verify which is the lower one. So I'll associate the cluster to them only. So in between these two values, C1 is lower. I say C1. Here also C1 is lower. Here C2 is lower. Here C2 is lower. Here C1 is lower. Here C2 is lower. There C2 is lower. Then C2 is lower. Then subsequently C2 is lower. So we make a cluster of groups. So if I say C1, I'm getting how much values? So I say 2 is in C1, and subsequently this is also C1. This is C2. Let me write it in C2 only. So this is sorry, to write like this. I have to refer these values. These are my x values, and I have to use these values for making clustering. Then next is C2. I'll say 10 will go in C2. Then again 12 will be going C2. 3 would be going C1, and 20 would be going C2. Then 30 would be going C2, and 11 and 25 is also going C2. So that's a cluster available. So we had make it two clusters based on our K2, where K1 is 4 and K2 is our 11. See, so now we are getting a mean here. So let me take average of this. Similarly, I do this. So this is my mean. So if my this value is equal to my K, which is my K1, K1 is my 4, and K2 is my 11. So if my this cluster centroids, you can say, are equal, then we say these centroids are good to go. We can go ahead. If they are not equal, then we'll change our centroid to new mean. Then we recalculate our case. Now let's go for the next. This time we are having K1 as a 3 and K2 as a 18. Then subsequently we'll be making two clusters, C1 and C2 would be there similarly, which we did earlier. So now we have to get this again absolute value, ABS. Then we have to minus my new centroid, which is 3. So I drag it. And subsequently I have to do this for K18. Again the same. Then we have to associate the clusters now. The lower value will be going in the cluster. Say I say this is my cluster 1, cluster 1, cluster 1, cluster 2, cluster 1, cluster 2, cluster 2, cluster 2, and cluster 1. Oh, sorry, cluster 2, because cluster 2 is lower one. So these are my cluster which I taken. So let me write down my new clusters. Say that's under C1 I'm having value. Let me write down this value again so I can refer it easily. So let me put it here. So my C1 is here, my C1 is lower, so I take C1. I'll take C2 also parallelly. This is again C1. This is again C1. Then C2. Then C1. C2. Then again C2. Then C2. Then C2. (11, 25). So again same process. I'll take average. and verify with the centroids which are given, which is nothing but 3 and 18. This is again not same. So I'll go for next iteration. I hope that would be my final iterations. So that is my mean. So let me take this value for now, 19.6. I'll take up new centroids. The K1 as 4.75 and K2 as 19.6. So I'll take a difference. I'll say ABS minus 4.75. Drag this. Then I say ABS minus 19.6. So I'll drag it here. So I'll allocate them at centroids C1, 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 again C1, again C1 is lower, then I say this is C2, this is C2, this is C1, this is C2. So let's see if we are methodically okay, then we'll verify it, C1 and C2. So in C1 we are having 2, 4, 10, 12, 3, 20, 30, 11, and then we have C2 as 25. Let me take average now. So let me repeat this formula, 7 and 25. We'll keep on repeating this until we get this, both the values are same, mean and centroids. So I'll say let it be my centroids was 4.75 versus 19.6. So K, this is my K1, this is my K2. So that's a centroid calculations. We'll be repeating it unless we have both the values common. So let me see in PPT, do we have, yes, 7 and 25 is my last centroid which is coming common. Okay, so let me do it last time. So I'm keeping this value intact. So this time my K1 is my 7.7, sorry 7, and K2 is 25. So let me take the difference now, ABS, say x minus 7, drag this, then I say absolute value of x minus 25 and drag it across. So when I make it clusters, this is belong to my K1, this is again K1, 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 K2, K2, K1, K2. So let me take this grouping first, C1, C2 grouping. This is my C1, sorry, this is C1 value, C1 value, C1, 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 again C2, C2, 11, sorry, this is here. I'll take up C2, this 25. So now we take average. Now if you see, now data is more or less same. So this is my mean and my centroid is the same. So till the time I'll get same centroid and mean, this is my final case. I can say I can put my centroids as 7 and 15 to make groups. That's a case which I prefer to go ahead. So that's a ecosystem of making this K-mean calculations. It is like you are making a random centroid, then you are taking a distance of all data values with your centroid and try to make groups. If group mean is same as a centroid value, then we are good to go as a k mean grouping.